Okay, we will start now. So today's lesson is electrical engineer practice. So electrical engineer practice is for the Bachelor of Applied Engineering. And also I will present you the electrical engineer workshop practice and also advanced diploma courses. So firstly, we're talking about the electrical engineer practice. For the electrical engineer practice, we can start from the aspect. So that will be the most important one is we have to be aware of the specification, and also the rule and regulation and the rate assessment of the electrical engineer. Those are the important aspects for the electrical engineer. So in this case, we have to be aware of in the electrical, when we are practicing the electrical engineer, we have to refer the appropriate rule and regulation. So in the state of the New South Wales of Australia, there are the New South Wales Electrical Service Rule. So this one is govern the electricity supply and the distribution, and also the electrical safety of the personal properties. So those are important aspects for the electrical safety of the personal properties. So that every electrical engineer and every worker, they must have the duty of care. The duty of care means an honest practice in the technical aspect as well as a legal responsibility. So when we are doing your professional job or the technical job, you must be honest practice. You must do this. You must act according with the honest practice, as well as you have to take the legal responsibility. So the New South Wales Work Health and Safety Act 2011 is the main rule and regulation which govern the safety in the New South Wales. So the safe work practice is an important aspect. When we are doing the safe work practice, all the physical activity and the chemical and the biological aspects and also the ergonomics and the emergencies practice, those are related to the safe work practice. So we are doing the job. In this case, you have to reasonably take care of your practice, and also every workplace has the workplace safety committee. So those workplace safety committee consists of the employer representative and also employee representatives, also union delegates. In the meantime, public relations, publics are also take part in those safety committees. So those are aspects of the safety committee. So when the serious injury happen, so in this case are two aspects. So you are doing the causing a serious injury because of you are breach of the duty of care. In this case, you will be responsible for the legal aspect. So you can face a legal action. So in this case, breach of the duty of care is not only the civil case, can also lead to the criminal case. So therefore, in the electrical industry, we have to be refer the appropriate rule and regulation. So AS 3000. So this is for the Australian electrical wiring rule. This electrical wiring rule is AS 3000 is now the 2018 edition. So we have to refer the latest edition. So those AS 3000 rules include the design, construction, testing, and the selection of the electrical installation. So those are the aspects. We are installing the electrical system in the industry. We have to refer the AS 3000 rule. In the meantime, we need to utilize the AS 3000 rule to install the electrical equipment. So in the meantime, this is for the utilization. Consumers utilization, we can utilize the AS 3000 rule. In the meantime, when we are doing the energy supply and the distribution, we have to refer the New South Wales Electrical Service Rule. So this New South Wales Electrical Service Rule is for the supply and distribution aspect. So in this case, this supply and distribution aspect are called as the routine. When we are doing the electrical installation in the building, we have to utilize the New South Wales AS 3000 rule, but for the supply and distribution, we have to utilize the AS 3000. So supply and distribution is AS 3000 New South Wales Electrical Service Rule, but for you are doing the consumer side of the electrical installation, we have to refer the AS 3000. So this 3000 rule got the two parts. One part is a safety and a standard, and part two is a practice. So part one is safety, and part two is a practice. The two parts are included in the AS 3000 rule. Therefore, we are doing the NDs so this 3002 is a part one is a safety and standard. So the part one explain the technical meaning, what is a safety standard, what are the aspects they are explained in the part one. But the part two is a real practice. When we are doing the electrical selecting the cable or we are to terminating or we are doing any other system. In this case, we have to refer to the part two. So this is the overview of the electrical practice in the Austrian industry. So any things are before you are doing this job. So first thing is that you have to focus on the risk assessment. So the risk is the most important aspect. Risk control is important. So that we have to do the risk control. Risk control include the elimination, containment, and the reducing. The first thing is that anything can cause any injury or any damage. The first aspect, the best one is that we have to do this elimination. So you have to eliminate totally. Instead of the dangerous equipment, we have to replace with the any equipment that do not get any danger. So this is the first thing. And also the containment. Containment means any dangerous machinery need to be put into the enclosure, appropriate enclosure. They have to utilize the appropriate enclosure to control and to retain and contain any dangerous material. And reduce means that if you cannot eliminate or you cannot contain, the best thing is that you have to reduce the dangers. So that in this case, reduce the danger means you have to utilize the personal protective equipment. So in this phase, we have to be aware of any hazards. So hazard can cause the physical and the work environment or the equipment or the work tasks and the work design. We have to utilize those aspects to reduce the hazards as much as we can. So the physical work environment we have to provide the appropriate safe work environment for the workers and the people in the industry. In this case, our working practice and the equipment, we have to be modifying the equipment we have to regularly check the equipment to get a safety standard. And what that is appropriate safe work practice need to be utilized, and what design must be the safe work design. So in this case, we are doing any risk assessment. So what type of the risk can cause to the people in the industry. This is the important aspect. So the risk can be the severity. Some of the risks are the varies can cause the serious injury or that can cause the death. And so this is for the how severe about the risks. What kind of the damage can happen in. So this is the risk assessment. If any equipment can cause the death of the people, for example, electricity can cause a death. So this is a very severe. So how much probability can happen? So probability assessment in the some time, it can be very high risk, but some other probability reduced. So we have to assess any probability. Another thing is a risk level. How often risk can happen? So this is the risk level assessment. So the risk assessment include the how much severity can happen or what about the probability and what is the risk level. So those are we have to know about the thing. So in this case, when we are assessing the risk, they are the 5 levels of the risk control. Then risk 5 is the highest one. This is the almost certain. So anyone who create the light electrical circuit will be electrocute. So this is the almost certain. Some are the likely, some are possible, unlikely, and rare. So those are the safety risk assessment level. In the meantime, what happened, the consequences. So any consequences can cause the catastrophic in there, and these are danger or any burning or the household can happen to the catastrophic. And some other major damage can happen, some moderate damage happen, minor damage, and the insignificant. Those are the level of the consequences. Therefore, when we are writing the planning the risk assessment control panel, we have to draw the table. So that this is what this column include the consequence, and here is a horizontal line include the likelihood. So that because of this one, in this case, the range can be there's this is we're going to rare or the high or medium or the very low. Those things you have to put into this cell. So by this way, we can assess a reassessment. So there will be the risk will be the high risk or medium risk, low risk or very low and low. Those things we have to put into this table. So that before you are starting as an engineer, before you start in any job, now you have to control the risks. So that there are the risk control aspect. Level 1 will be the eliminate the hazard. We have to eliminate all hazards together. So this means that we have to replace all the dangerous equipment. Level 2 means that you have to substitute the hazard. Substitute the hazard with the something safer. So if you cannot eliminate that equipment, you have to utilize any safer equipment. And another thing that we have to isolate the hazards. We have to isolate the hazards from the people. This means the appropriate container, appropriate barrier you must provide it to protect the people, not to get any injury or any damage. And also we have to reduce the risks. We have to reduce the engineering design and any other control aspect we have to apply, and by this way you have to reduce the risks. Level 3 means we have to reduce the hazard by using the administrative action. Administrative action means the appropriate assigning the rotation of the job or the appropriate assigning the work environment or the workplace. For example, sunburn is a very serious for the construction worker. When we are working at the outside without any shade, and then during the very hot day or the peak summer time, about 12 to 2 p.m. is the most serious thing. So that time the sun rays can fall into the body very much. So in this case, we have to reduce that risk. So to reduce that risk, the best thing is you have to rotate the shade. Instead of asking the worker to do the outside job, the administration allow the worker to walk into the shade. So this is the things we have to administrative fashion. So those are the important aspects of the reassessment. So this table means any reassessment. Before you are doing any reassessment, we have to follow the appropriate reassessment procedure, and we have to identify the risk, any danger we have to identify, and we have to control those danger as well. So this means that reassessment is important for the here is we need the government control. Government need to control the appropriate rule and regulation. In the meantime, those government actions need to be followed by the contractor and these service department. In the meantime, we also have to produce appropriate new report. So the safety inspectors have to provide the news and report. And then those reports are included the visual inspection, identify the problem, propose additional things. So those are important aspects of the reassessment. So that in the meantime, those are reassessments that you have to site visit, and also we have to identify the problem. In this case, include the visual inspection, identify the possible problem. Those are prepared by the reassessment report. Those reports are submitted to the government, and the appropriate legislation is imposed by the government. And those then appropriate rule regulations are produced by the government authority, and the contractor and the service people must follow them. So this is an important aspect of the reassessment. So in this case, we have to apply the appropriate occupational health safety plan. So in this case, you are doing any solar electrical installation. In this case, you have to follow the appropriate solar electrical safety. When you are working at the height, appropriate working with the heights at the heights of safety, and also the electrical safety, heat temperature safety, important aspect. In the meantime, we have to also assess the risks, and also the electrical safety aspect, also the environment protection. Those are the important aspects of the reassessment. So that before you doing anything as an engineer, appropriate communities cooperation is also important. Computer licensing is also important aspect. So that any material acquirement, project schedule tasks, and also the cooperate with the community is important aspect of the electrical engineer. So this so these electrical engineer must have the appropriate technical background. In the meantime, when we are doing the job, in this case, you also have to do the appropriate ethics, professional ethics. Before you are finishing any contract job, you accept the job with the one company, so that when you are going with the next company, and that time another company offer you another job with the better pay and condition. So in this case, you have to be aware of. You cannot simply draw everything and you cannot go to the other side because of the it is an unethical. So you have to negotiate with your employer to refer your responsibility. You have to refer your current job or the current document to your current employer, and then appropriate substitution need to be determined by your employer. Everything okay, everything clear, then you can take up the another job. So this is the important aspect of the important aspect of this ethical process, ethical ethics. Therefore, as an engineer, your must have the appropriate design. So you have to design your project. In the meantime, you have to manage a bid. So tenders are bid. Tender bids means that sometimes you have designed any estimate or design to win a tender. In this case, you have to utilize the appropriate rule, regulation, and standard, appropriate pricing. You have to follow, and then utilize, and then you have to manage the tender bid. If you are the engineer who select any tender submitted by the contractor, in the meantime, you also have to be honestly do the practice. You have to see compare all the tender one to another, and also cost effectiveness, safety aspect, work procedure. Those you have to be properly defined, and then you have to select the appropriate tender. In this case, you have to be aware of the specification and the work procedure and the process. Those are the important aspects and very related to this technical background. So you got this knowledge and the technical background. You can design the tender and just do the designing. In the meantime, you can appropriate select the tender. So this is the first aspect. Another thing is that we have to utilize the appropriate tender bid to assess the application of the IDAS company. So those tender bids include the specification and the work procedure and the process. They are related to the finance. So that if you select the tender with a very high cost, in this case, your company will lose a profit. So this is why that selecting the tender is important aspect. If you select the tender with a very low price, but then no quality, in this case, your job can be damaged. So this is your reputation can also be damaged. So this is important aspect of your assessing the tender. So that you have to use that tender bid to assess the application of the other companies. So that as an engineer, you are responsible for the design and also the rate assessment, safety assessment, and the communities cooperation, and also the designing and the managing the tender bid or specification, work procedure. They are related to the finance. So this is an important aspect of the electrical engineer. So now things we are installing the electrical equipment, so we have to be aware of the protection system. Protection system is simply disconnect the supply when the touch voltage is greater than the 50 volt. This means that allowable touch voltage is 50 volt. So before you are disconnecting any equipment from the supply, you have to be aware of how much touch voltage can happen. So this is the formula to calculate the touch voltage. VT is a touch voltage. VO is an operating voltage. This means 240 volt system or single phase. ZBE means protected acting conductors are impedance, and ZA means the impedance of active conductor. So this formula has been utilized. We use this formula to determine the touch voltage. For example, impedance of the active conductor is 1 ohm, and protected acting conductor is 2.4 ohm, and the supply voltage 230 volt. In this case, we can calculate the touch voltage. VO multiplied ZB divided by ZA plus ZBE. So that this is the you can VOs are you substitute the 230. And ZB is at 2.4, ZA1 plus 2.4, so then you can calculate the voltage. So this is what you can calculate the touch voltage. So as an electrical engineer, before you are disconnecting the anything, because of the especially that you are upgrading the electrical system, you have to disconnect the all electrical supply, all the wire, and you have to reinstall the whole system. So that before you are disconnecting the anything, you have to be aware of the touch voltage. This is a touch voltage calculation. Another thing is a for loop impedance. For loop impedance means this is for the V75 operation temperature, 75 degrees centigrade. V90 is operation temperature 90 degrees centigrade. When we are looking at the electrical cable, some cable you can see the V75, some got the V90. V75 operating temperature is 75 degrees centigrade. V90 is operation temperature is 90 degrees centigrade. And then we also have to aware of the for loop impedance. For loop impedance means the current flow from the source to earth. So this is the total impedance. So this system you can see that this is the equipment, electrical point of supply. This is the fault. So the electrical currents you can see that this is the consumer main. Consumer main, here is a main switch, and this is for the equipment. So this is E and D is this is the equipment we utilize this equipment. So those equipments are from this equipment. The electrical fault happens, therefore we come through the main supply and go to the supply neutral. So from the neutral side, it can go to this neutral bar and the up bar are connected. So that the current will go to this R. So that will be the total impedance can be calculated. Z is a ZAB. ZAB means from the A to B. Impedance. Here supplying the active conductor to A to B. So this is A supply. This is equipment point of supply. So from the conductor to the point of supply, ZAB. ZBC means here is you consider this is a B point. Here is C point. So B to C point impedance. ZCD. So here this C point to the equipment is a ZCD, and also you can see there's a ZFG. FG is a external impedance, and also the ZGA. ZGA, so go to the other system. So this is for the Z external. Internal impedance is ZDE. So this is in the equipment you can see the impedance ZDE. So the total system impedance is Z external and Z internal. So external impedance AB plus BC plus CD plus FG plus GH. Internal impedance is DE. So by combining, then we got the total in system impedance. So this is the way we have to calculate the system impedance. So that in this program, we can see the supply transformer voltage is at 230 volt, and active conductor side 0.25 ohm, and also the ZB is at 3 ohm, and also the equipment impedance is this is all the 3 ohm, and also ZB is other system 3 ohm, and also from this up to the distribution board is 0.15 ohm. So those are the impedance given. So that we can calculate the total for loop impedance by adding the all. So this is the way you can calculate the for loop impedance. So this will be we calculate the for loop impedance. So ZBA, ZA, ZAN, ZBE, ZBEN. So this is the thing we add. So this is the 9/5 ohm. So if you got a for loop impedance, you can also calculate any fault current. When the electrical fault happens, the current can be calculated. Supply voltage divided by impedance. Supply voltage by impedance, then you can calculate the fault current. So in this case, not to include the for loop impedance. If sometimes you don't need to use a for loop impedance, in this case you can put the for loop. This one is a ZA and is 0. then we can calculate the maximum fault current can also be calculated. So this is the way we are calculating the maximum fault current. So this problem is a supply transformer. Supply voltage 230 volt and circuit breaker, the rating is at 20 ampere and also the socket outlet is at 10 ampere. We have to calculate the for loop impedance. So in this case, how to calculate this for loop impedance? So in this case, this supply circuit breaker is type C. Type C circuit breaker. So we have to refer the ASR 3000 table 8.1. So type C circuit breaker, and then the current is a 1.53 20 ampere. So then this is the for loop impedance is a 1.530 ohm. So this is the way we can find out the for loop impedance. You refer the AS 3000. So AS 3000 rule and look at the table 8.1. So you can see this type of the circuit breaker. Type of the circuit breaker type C and current rating is at 20 ampere. So from that table, you can get the for loop impedance is 1.50 ohm. 530 ohm. This is the way we find out how the for loop impedance. Okay, so this is the things AS3000 rule. So table 8.1. Table 8.1. Here is a table 8.1. So this problem, give the circuit breaker type C circuit breaker and 20 ampere rating. So what should be the for loop impedance? Therefore, you have to refer the AS3000 rule, tables are 8.1. So this is table 8.1. So type C circuit breaker and 20 ampere here is a 1.5. So current, so for loop impedance is 1.5. So this is the way how we calculate the for loop impedance. So this is in this case, as an electrical engineer, you also need to know how the appropriate for loop impedance. So this is the appropriate for loop impedance calculation. So we have to refer the appropriate for loop impedance before you start doing the anything, any electrical installation. This is the for loop impedance, how we do the for loop impedance. So you refer the appropriate the AS3000 table. Now thing is we utilize the HRC fuse. HRC fuse is high rush charging capacity fuse. This fuse is we utilize to do this emergency cutting off the electrical supply. So in this case, HRC fuse is utilized. So HRC fuse rating is 25 MVR, 25 MVR. So the HRC fuse is operate within the 0.4 second. So in this case, we have to calculate the date installation. We have to calculate the for loop impedance. So we also have to refer the table 8.1, table 8.1 for the for loop. So we refer the AS3000 rule and table 8.1 as well. So we go to the section 8. So this is table 8.1. So table 8.1 means if you are installing the fuse on the final sub-circuit, there are two kinds of the fuse. HRC fuse has the 0.4 second operation time, and normal fuse are 5 second operation time. So in this problem, this one is given the 25 MVR rating, 25 MVR rating and the HRC fuse. So 25 MVR rating and HRC fuse, high rush charging capacity fuse. So the 25 MVR and the HRC fuse 0.4 second. You can see the Y/6 ohm. So the Z4 impedance, for loop impedance is Y/6 ohm. So from here you can calculate like this. So another thing is as an electrical engineer, you also need to set the circuit breaker. Well, when we are installing the electrical installation system, so that you have to protect your circuit. In this case, you need to utilize a appropriate circuit breaker. So this is a selection of the circuit breaker. There are three kinds of the circuit breaker. Type B is a 4 times rated current. Type C circuit breaker is 7.5 times rated current, and type D is a 17.5 times rated current. So there are three kinds of the circuit breaker we are using. So this problem is given the we are supplying the 100 ohm. So this motor or this coil got the 100 ohm. We connected to the 230 volt. So in this case, how much normal current is flowing into this system? So the 230 volt divided by the impedance 100 ohm, you got the 2.3 MVR. So this is normal current is 2.3 MVR. Then this is a normal saturation. Then electrical fault happen. Fault happen means the fault impedance it fall down to the 10 ohm. 10 ohm means that normal full circuit is a impedance 100 ohm, but when the electrical fault happen, the impedance is reduced significantly. Therefore, they reduce our impedance, and we have to utilize the supply voltage. So supply voltage divided by the reduced impedance. So 230 volt divided by 10 ohm, you got the 2.3 MVR. So this is for the fault current is a fault current 23 MVR. So then we have to find out the ratio between the normal current and the fault current. So normal current is 2.3 MVR, fault current is 23. So divided by 23 by 2.3, you got a 10. So this ratio is a 10. So we have to find out the distance. What kind of the circuit breaker is suitable? Type A or type B or type C or type D. In this case, if type A is only 4 times rated current, type C is a 7.5 times. But here is a fault current and normal current ratio is 10. So this should be you can use a type C, but you can utilize the type D. Type D is up to 70.5 times. Therefore, you can utilize a type tidy circuit breaker. Tidy circuit breaker and also the 2.3 ampere. So then tidy circuit breaker 2.3 ampere, tidy circuit breaker and 2.3 ampere. So then you can find out the appropriate in so tidy circuit breaker 2.3 ampere. So 2.3 is in the you can see the ASR 3000 rule. Table 8.1, there is a no 2.3 ampere, minimum is 6. So the tidy circuit breaker and the protected rating is there is no 2.3, only 6 available. So you say utilize and tidy circuit breaker. So there will be the minimum maximum output impedance is 3.10. So this is the way we find out the output impedance. So this is the program I repeat again. We have to use a normal current, normal impedance 100 ohm. When the electrical fault happens, is a fault impedance 10 ohm. Supply voltage 230 volt. What kind of circuit breaker is suitable? So in this case, we have to find out we calculate the normal current first, normal voltage divided by normal impedance, and also that we calculate the fault current, so the supply voltage divided by fault impedance. Then you got the fault current, you got the normal current. Then we find out the ratio. Fault current divided by normal current, so you got the ratio is 10. Then you can see the 4 kinds of the circuit breaker, type B or type C or type D. So we have to utilize the type D because of the ratio between the normal current and the fault current is a 10. So type D is a suitable. So you have to select the type D. Type D and also the what about the current? The normal current 2.3. So 2.3 ampere. This 2.3 ampere and type D. So then you can look at the tables 8.1. So type D 2.3. There is a no 2.3. The minimum is 6. So the 6 ampere you select and type D. So in this case, you find out the follow impedance 3.1. So this is the way how we find out the follow impedance for this system. You know the normal current, normal impedance, you know the fault impedance. Then you find out the ratio between the normal and the fault current. And based on the ratio, you select the type of the circuit breaker. And then type of the circuit breaker and the normal current rating. Then you refer the table 8.1 of the AS3000 2018 edition. Then you can find out the appropriate for loop impedance. So this is the way we calculate the for loop impedance like this. Now this program is given. So there will be the supply voltage is a 0.28 ohm supply system, and then the distribution both of the consumer may got the cable is a 25 millimeter square cross in the area and a 15 meter long. And also the final circuit 6 millimeter squares are cross in the area 25 meter long. And for applied, so the applying 40, that impedance is a 3 ohm. Final circuit, there will be the cable size is a 4 millimeter square and a 25 meter long. And distribution of consumer mains are their cable size 35 millimeter square and a 50 meter long. So we have to find out the following impedance, and also we have to find out the maximum fault current, and applying the system is a 3 ohm, we have to find out the fault current. So those things you have to find out. So in this case, we have to refer the appropriate table 25. So in this case, you have to utilize the appropriate manufacturer information. Manufacturer information means the type of the conductor crossing the area and the length and what should be the appropriate impedance. So this is you have to refer the appropriate manufacturer table suitable for your cable. So this cable is a 25 millimeter, 50 meter. So in this case, 50330 ohm. So this is you get from the manufacturer table. Similarly, 6 millimeter square, 25 meter, 4 millimeter square, 25 meter, 35 millimeter square, 50 meter. So those impedance you got, you add all impedance, you can calculate the for loop impedance. And after that, though you got the for loop impedance, supply voltage 230 volt. So the supply voltage by the for loop impedance, you got the fault current. So fault current you can calculate. By this way, you can calculate the fault current. So after you know, sometimes you also have to calculate the maximum circuit length. How much circuits length should be utilized. In this case, we have to find out the Z internal impedance. So this equal formula we have to utilize. So Z internal impedance is 0.8 multiply supply voltage divided by normal current. So this is the way we calculate it. So the maximum circuit length we calculate by this way. Okay, this problem is a final circuit. Final circuits are supplied a load consisting of the range in a domestic installation. It's produced by the 32 ampere Type C circuit breaker. So the way to find out the maximum internal follow impedance and also the final circuit based on the 230 volt and supply voltage are available. So the firstly we have to know about the 32 ampere Type C circuit breaker. 32 ampere Type C circuit breaker. So you refer the table 8.1. So this is table 8.1, 32 ampere Type C circuit breaker. So there will be 32 Type C. So there will be the follow impedance is 1 ohm. So from here you got the follow impedance is 1.96 ohm. 32 ampere Type C circuit breaker.
Well, we need to pay the my God. Vậy là
Không phải.
anh mà lên đi về này đi. Vậy là như là niêm mà câu nó này vào một nước này.
So that then you got the here you got the upward impedance. Then you multiply with the this one, and then you multiply with the internal impedance. Multiply with 0.6, 0.8. Then you got the impedance. So this is the way we calculate. The next one is we also have to decide the maximum circuit length. So what should be the maximum circuit length? So we utilize this formula. M maximum is 0.8 multiplied U0 SPH SPE divided by IA rho SPH plus SPE. M maximum is maximum root length of your cable. U0 is a normal supply voltage. Rho is a resistivity of the conductor. So then you substitute. In this case, 22/5 into 10 power minus 3 for the copper conductor. Millimeters unit is ohm millimeter square divided by meter. And for the aluminum, 36 into 10 power minus 3 for the aluminum. And IA is a trick current setting. So trick current setting is an ampere. SPA cross-sectional area of active conductor. And SPE is a cross-sectional area of the protected active conductor. So those things are you have to find out. So the if you know the supply voltage, U0, SPA is cross-sectional area of the active conductor, SPE is a cross-sectional area of the conductor, IA is a trick current setting, rho means the resistivity of the conductor. Then the those factor you substitute in the formula, then you can calculate the maximum root length. So this means how long are you should draw the cable. This is the maximum circuit length. This maximum circuit length is depending on the several factors. They include the supply voltage, also conductor, that is cross-sectional area, also the active conductor cross-sectional area. In the meantime, you have to set up the trick current. Trick current is how much current setting you have to be utilized at the circuit breaker. the peak current setting, and also resistivity of the conductor. Those factors are determining the maximum circuit length. So if you put the all data, how much of your conductor side will be utilized? Conductor side depending on the supply current. In the meantime, conductor resistance, conductor size, and resistivity, supply voltage, and how much current you need to be quick reading, quick current reading. Those factors you substitute in the just formula, then you calculate the maximum circuit length. So the maximum circuit length is an important aspect. So that when we are doing the emitter protection is important. When the current is excessive, it can cause an overload. In the meantime, excessive fault current happen, it can fault leakage current happen. So that because of the excessive fault current, it can cause a insulation failure. When the insulation failure, you can your circuit, the whole thing can cause a fire. Therefore, that we have to be aware of the distance. So therefore, in this case, how to select the appropriate cable size, we have to utilize the AS3008 rule to select the suitable cable size. So this is the how to select the cable size and how to select the how long you should run the cable in the whole circuit. We calculate by this way. In the meantime, any heat energy production. When the electrical current is flow into the wire line, so depending on the current, resistance, and the time, heat energy can happen. So heat energy can be calculated by the formula H equal to I square RT. A is the heat energy in joule, I is the current, I is the resistance. So the fault current, normal, this is the red one is a normal current, and red one is a fault current. So when the fault current happens, fault current is a much more than the normal current. So that all the circuit breaker need to operate it before fault current level reach the maximum. When it reach to the 25% of the peak, the circuit breaker must operate. Otherwise, once the fault current reach the maximum point, so equipment has already been damaged. So this is a no point to provide the protection equipment. Therefore, this is very important. When we are setting the appropriate protective equipment, before reaching to the peak point, about the 25% of the peak is reached, that time circuit breaker must operate. So this is the way we protect the circuit breaker. So circuit breaker setting is an important aspect. Another thing is we have to follow up the ASR 3000 2.5/1 clause. So this is the AY 3000 2.5/1 clause 2.5/1. So we look at the what is a clause 2.5/1. Okay, this is 2.5/1 general. So in this case, 2.5/1 is a general requirement. So active conductor shall be protected by the one or more devices that automatically disconnect the supply in the event of the overcurrent. Before such overcurrent attain the magnitude of the duration, that will cause the injury to the person or livestock or the damage because of excessive temperature or electromechanical stress in the electrical installation. This means that when the overcurrent attain the magnitude, in this case, protective devices must operate. So in this case, our protection against the overcurrent means we have to utilize the overcurrent protection across the clause 2.5/2 and 2.5/3, short circuit protection 2.5/2 and 2.5/4. So the 2.5/2 is the short circuit protection and also the maximum circuit protection. Those things are important aspects. So that we have to follow the appropriate overload current and the short circuit current protection. Those are the clause 2.5/1 of the AS 3000 rule. So therefore, the important aspect is there are three aspects: actual current of the consumer conductor, So this is the maximum demand current, IV. IV means the actual current in the consumer conductor, maximum demand current. Maximum demand current means that when you are install the electrical installation, in this case, you install the light point, you install the socket outlet, you can install the any lighting point, and also heater. We have to refer the AS3000 appendix C1, C2, and C3. So that we see, look at about the appendix of C1, C2, C3 of the AS3000. So this is the appendix table. Table C1, C2, C3 are utilized to calculate the maximum demand of the consumer made. So table C1. Table C1 means a lighting load group. So then we single domestic installation. We have to utilize the 3 ampere for the first 1 to 25, 2 ampere for each additional 25. And this is the block living unit, 2 to 5 living unit, and 6 to 20 living unit, 25 or more living unit. This is the lighting we calculated. And for the outdoor lighting, that is 75%. And this is for the lighting point. If you can count how many lighting points in the building, then you can apply the appropriate buildings are plan, then how many lighting points. So the we have to refer. If your installation is single domestic installation, 1 to 25, 3 ampere, and additional 25, you add the 2 ampere each. And for the block, 2 to 5 living unit, you follow this rule, 6 to 20 and 21 for more. Similarly, socket outlet, they are there not exceeding 10 ampere, single domestic, we refer as this rule. Block living, you refer as this rule. And socket outlet more than 50 ampere, you just take the 10 ampere. Electrical installation, more than a 20 ampere socket outlet, you can take the 15 ampere. This is depending on the load group. Depending on the load group, you can select the appropriate maximum demand current. In the meantime, if you install the range or fixed circuit heating or the instantaneous water heater, storage water heater, those are the load group. So table C1 for the domestic installation load group. So this is I just explain you the what is the how to calculate the maximum demand of the electrical circuit. We refer the table C1, C2, C3. So more detailed aspect I will explain in the electrical trade study. And this is the table C1 for the domestic. And table C2 for the industrial. This is the table C1. So that AS3000 rule, you can refer the page of 466, 465 and 66, you can see the table C1. And then you can see the example problem. You can look at the example problems of page of 468, also the page of 469, and also page 470. Those pages are on the those pages are we can look at the example problem. So this is the domestic installation. We use the table C1. Non-domestic installation, there are 2 types of the load. In this case, we have to utilize the table C2. Residential institution, boarding house, hospital, accommodation, house and model. We use the domestic installation. Non-domestic, they are low group. In the meantime, factory, shop, store, office, business premise, we utilize a non-domestic installation. This is also we utilize a that's low group. So in this case, lighting and the socket outlet, we refer the those group. So this is for the low groups selection. So this is for the non-domestic installation. We refer the table C2, and then you are also look at the table C2, and then you can follow the some example problem how to calculate the consumer installation. The next table C3 is a maximum demand method, non-domestic installation. This is based on the energy demand method. Every 1 meter square, how much of volt ampere happen depending on the office car park. Depending on the office car park and you can calculate the maximum demand. So those maximum demand calculation for the domestic car office and also the retail shop, warehouse, and light industrial complex, we calculate the maximum demand. So that maximum demand is depending on the area. You look at the area of your electrical installation, then you can determine the appropriate volt and their range. So this is the three things we have to refer. So the AS3000 rule. So table C1 for the domestic electrical installation, table C2 for the non-domestic installation, and table C3 for the maximum demand method based on the energy demand method. So this is the way we calculate. Therefore, when you are selecting the appropriate circuit arrangement, the first thing is IB. IB is an accurate current flow into the conductor. This is related to the maximum demand. So to calculate the maximum demand, important one is we have to refer the AS3000 rule, appendix data C1, C2, C3. C1 for the domestic installation, C2 for the industrial installation, and C3 for the energy demand method. So IB is we have to calculate according to by referring the AS3000 rule, appendix data C1, C2, C3. This is the IB. IA is protected device rating. Protected device rating means we have to utilize appropriate circuit breaker rating and a fuse rating. So how to select the protected device rating? We refer the AS3000 rule and table 8x1. So this is the AS3000 rule. We go back and look at the table 8x1. So this is the table 8x1. Table 8x1 is we use this is the table 8x1. We got the circuit breaker, type B circuit breaker, type C circuit breaker, type D circuit breaker. So they are the operation time is 0.4 seconds. In the meantime, you can also utilize the fuse. Sometimes circuits are protected by the fuse. So HRC fuse operating time is 0.4 seconds. Normal fuse is 5 seconds. So how much fuse are protected by rating and also protected circuit breaker. So this is for we have to select the appropriate circuit breaker and we have to protect this device rating. So this depending on the fault loop impedance. So fault loop impedance means that when the electrical fault happens, at the conductor to fault, how much to the resistance? This is the fault loop impedance. You need to calculate the fault loop impedance. Then depending on your kind of the circuit breaker selection, then you can determine the protected device rating. So this protected device rating is the one. This is for the IN. IN is a protected device rating. IZ. IZ is continuous current capacity, carrying capacity of the circuit. Continuous current carrying capacity of the conductor means you have to refer the AS3008. AS3008 is this is for the cable selection. So the cable selection rule, we have to refer the AS3008. How to utilize the AS3008? I will explain in the electrical trade. Now that I am teaching the electrical engineer aspect, overview of all the system, all the reassessment, all the circuit selection, I can teach in the overview. And details are selection, detailed cable selection, details are installation, I will teach in the electrical trade. So this goes into the three aspects. Electrical engineer, designing looking at the whole system, and also the electrical trade. This is the detail aspect. And electrical diploma. This is for the bridging between the electrical engineer and the electrical tradesman. So there are three aspects are included in the Bachelor of Applied Engineering. Now that I'm talking to you about how to arrange the whole system current, the equipment. So how to set the protected devices, how to configure with your conductor, supply conductor, and also how to select your cable side. I am giving you the overview picture. So there are three aspects of the current. In the electrical installation, there are three current you have to be aware of. IB is actual current in the conductor. maximum demand current. Maximum demand current is we have to refer the air 3000 appendix table C1 to 3. So this is the air 3000 rule, appendix table C1 to 3. Go and look at this air 3008. So the table C1, C2, C3, you can get it. So table C1 for the maximum demand calculation, depending on the lighting load, socket outlet, how many domestic electrical installation, how many block, you can select the appropriate current. This is for the maximum demand calculation for domestic. And table C1 for the maximum demand calculation for domestic. And table C2, table C2 is a non-domestic installation. Non-domestic installation include the two kinds of the load: residential institution, hotel, boarding house, hospital. This is the one group. And factory, shop, business, school, those are the another group. So two kinds of the load group. Depending on the two kinds of load group, whether you are installing a lighting or power or socket outlet, then you can calculate the maximum demand. So this is the way non-domestic installation. Table 3 for the you calculate this area, look at this your drawing, then you can determine how much volt ampere. So this is the things electrical current you have to calculate. This current is an IB. IB means depending on the current maximum demand calculation, you can select the IB. IM means protected device rating. Protected device rating means that you have to refer the table 8x1. So table 8x1 circuit breaker rating. Here is the table 8x1. You can look at the circuit breaker. Whether you are using the circuit breaker type B or type C or type D, or the protected fuse, you can select the circuit breaker. So this is what the circuit breaker rating.
呢個係而家 meeting 啊，呢個係個 meeting 啊嘛。你想熄咗佢
So this is for the circuit breaker rating. Circuit breaker is a table 8x1 circuit breaker rating. So you look at the table 8x1, there will be the type B, type C, and type D circuit breaker, and also the final sub circuit. Final sub circuit. So this is for the your depending on the output impedance and depending on your circuit type of the protected equipment, you can calculate the protected device rating. So that protected device rating is this one. This is for the IN. IZ means the continuous current carrying capacity. Where the electrical current is drawn by the supply system, we have to select the appropriate continuous current rating by using the AS3008. So that this is the configuration. IV must be less or equal than the IN or the less or equal than the IZ. This means the actual current must be less than or equal the protected device rating, or the less the protected device rating must be less or equal than the continuous current carrying capacity. So this is the way we have to arrange the supply wire. In the meantime, another thing is that I2 is less or equal than the 1/459 IZ. I2 is effective operating of the protected device, and IZ means a continuous current carrying capacity 1/45. So you multiply with 1/45, IZ by 1/45, it must be less or equal than the I2. So this is for the effective operation of the protected device. So this is the way we have to select the appropriate current rating. So this is the configuration of the electrical circuit. Okay, so this today's lesson, I'm talking about the electrical engineer aspect. Electrical engineer aspect is I talk about the rule and regulation. I summarize my lesson. For the electrical engineer, we have to be aware of the appropriate standard rule and regulation. So the reassessment is the first thing. So we have to operate according to the reassessment. Before you start in any job, you need to assess a risk. How much a risk can happen? So this is important aspect. So in this case, the reassessment is important aspect. So in this case, we have to repair the duty of care, New South Wales Work and Safety Act, and you have to follow the appropriate reasonable practice. This is also important aspect. Now this is for the legal framework I'm talking about. We also have to follow the appropriate risk assessment, how to design a risk. And as an electrical engineer, you need to design an electrical system. In this case, the most important thing is the AS3000 rules have to be utilized. So I explain you the AS3000 rule. And also I talking about the risk assessment data. And then firstly is important is we are talking about the contract procedure. Contract procedure bidding or your ethical practice I explain about. And then I talking about the protection system. Because you are doing the electrical system, important one is a protective device is an important aspect. I talking about the follow impedance and also the follow impedance calculation, also the protective device rating. We talking about how to set the AS3000 rule, how to refer the table, how to select the current circuit configuration. Those are I expect. This is for the electrical engineer aspects. Okay, this is first part is an electrical engineer aspect I explained about. Second part is we are talking about the electrical trade practice. Electrical trade practice 1. For the higher electrical trade aspect. Okay, we're talking about the lighting circuit. So this is a one-way switching for the look at the light circuit one. So this is for the active, the neutral, so light by 1, light by 2, and connected to the neutral. So the firstly, electrical, this is the active, active and it's a neutral. Circuit power to the light path. So this is for circuit going to the switch and go to the light. And also we have to provide the separate wiring for the control. Likewise, a button holder or the ceiling rose. Power for the main light is taken from which the light is active. So this is for the first light and second light likewise. So this is for the circuit diagram. One-way switching more. Every one way. This is a switch connected to the light by 1 and light by 2. So this is for the when you see the socket out there. This is the controls diagram. So they will be the switch. This bottom 2 are the switch. This is for the your light. So at the back of the your ceiling rose, you can connect like this. So this is the is connected. Here is a switch wire, active wire is red one. So active wire go to the this is the switch C12. C12 is at the switch. So the active wire go to the C. Another from this C, another go to the C point. So this is a common terminal. So active wire go to the first switch as C, another switch C point. Then number 1. So number 1 point connected to the your light point. So light point here, this and this one. So this top and bottom one, they got the connection. So they got the connection, they go to the here. And after that, the another side is connected to the opposite side. So opposite side point, this is opposite point. This is connected to the neutral. and then connected to neutral. Then up wire is a given on your light. So this up wire is connected to blue wire is connected to up. So this is the way we can connect it. So this will all the active neutral and the light have been connected. This is a look at the switch. Look at the switch point. Look at the switch point means active wire go to the C point and from another C point go to another active wire. So this is the C1, 2 are the switch. So active wire go to this C point, another C point. And then number 1 connected to the light wire. So before this point and this 2 point, we have to connect your light. So we can connect, and out of the opposite side, we connected to the neutral wire and connected to neutral to the neutral. And then a terminal is given, so the all a terminal connected join like this. So this is for the look at the switch installation. So then looking at the switch wire, they require the main circuit active to be looped from the one switch plate to next and maximum one active neutral up and the switch. So this is for the look at the switch installation. So when you are connected, important one is a switch must come in first. Active to switch and then light to neutral. If you put the light after you put the switch, it's a wrong. Because switch must be installed at the active wire. And here is a connection of the two-way switching circuit. Two-way switching circuit, this is the switch 1, this is 2, this is light to neutral. So this is a two-way switching circuit. Two-way switching circuit, this diagram you can refer as a two-way switching. Look at the switch suitable for two-way switching circuit. So this is the switch. So there will be active wire go to C, and then number 1 is connected to the number 2. This number 2 point connected to number 1. After this C point connected to the light, and after that this one coming is a neutral wire go to a neutral point, and here is a connection. So this is the two ways of light connection. This is circuit diagram. This is accurate wiring diagram. So two-way switch connection diagram we can utilize like this. It is two-way switching. So if you also so two-way switch means the appropriate number of the final circuit need to be arranged to protect the overheating of the wire. And then it needs to be separate lighting and a power circuit. Lighting circuit and a power circuit need to be separated. And then cable side is you have to utilize a cable side by referring the AS3008 or the AS3000 2018 debate selection. Addition, you have to select the cable side. So the 2000s are AS3000 effective stable CA utilized to determine the maximum demand. So the standard cable size is a 1.5 millimeter square. So this is what the standard cable size, and minimum size and non-domestic installation can be 2.5 or 4 millimeter square cable. So this is for the general information regarding the connections of the electrical lighting system. In the meantime, you also have to know about the operating temperature limit. When we are installing a cable is installed in environment with the higher or normal ambient temperature or within the thermal insulation need to be derated to carry the less current or upgraded in the side. So this is for the normal operating temperature. We have to derate the cable. So the upgrading the temperature rating. V75 is a 75 degrees centigrade operating temperature. Instead of using the V75, you can use the V90. Because of the, if the cables are derated, means that you can increase the cable size or you can utilize the cables upgrading the temperature rating. So depending, because of the only single cable is installed in the circuit, is not a problem. But if you are using the multiple cable, they will mutually induce the electromagnetics and mutually induce the voltage. Low electromagnetic and voltage will increase the current. So this is why we have to select the appropriate derating of the cable size important. So the cable size derating is you can do by two ways. One thing is you can select the bigger cable by using the AS3000. You can select the one step bigger cable AS3008, one step bigger cable, or you can upgrade the temperature rating. So instead of using the 75 degrees centigrade, you can upgrade to P90. So this is the ways that cable derating is also important aspect. And another thing that we also have to provide a fire safety. We have to protection against the thermal effects. Land boilers are the high temperature sources, so the downrise require the education area in roof space to round the heat to dissipate, or otherwise they can start the fire. Spotlight cannot be too close to the object. So this is for the ceiling, appropriate ceiling side. This is for the you use the thermal insulation, and also the you use the any transformer. So above BNC. BNC means clearing above the ABC. A is clearing above the luminaire. So in this case, incandescent light is 50 millimeter, halogen light is 200 millimeter. B is a side clearance. Side clearance is 100, incandescent 100, halogen light is 200 millimeter. Here C is a clearance from the thermal insulation. That will be the incandescent 50 millimeter, halogen light is 200 millimeter. D is a clearance from the transformer. If you use the transformer, the clearance is also D. So this D means about 50 millimeter minimum. So this is the ways appropriate clearance important aspect. When we are installing the light, appropriate clearance from the ceiling, from the equipment is also important. So this is also we have to utilize at this stage. In the meantime, we have to this is for the fire safety. Because of the lead and the boilers are the high temperature source, downlight require the educate area and roof space to allow the heat to dissipate or that they can start the fire. Spotlight cannot be too close to the object. So this is for the appropriate transformer side, and the boiler rating is also important aspect. And here is you can see about the main switch and the RCD. So this is for the installation is uplink, neutral link, RCD neutral. So this is the residual circuit device is installed from the main switch, go to RCD and connected to the light. And also the neutral connected to the RCD neutral, and then RCD neutral connected to neutral link, and also neutral link is combined with the uplink and go to supply. So this is for the main switch connection, RCD and the lights are configuration. So the class 1 is you have to complete this diagram. So here you got the light by 1, light by 2, light by 3 are given, and switch 1, switch 2 are given. At the neutral arc, you have to complete your circuit diagram. So this circuit diagram given, you have to connect this as real connection diagram. Then you have to choose a correct answer. In the look at the switch system, the active and neutral wires are firstly connected to switch, and then spray wiring is installed for the control. The active and neutral wires are firstly connected to light, and then spray wiring then connected to this, taken for the switch. And then here is the unlinked neutral link and then RCD neutral link. Here is RCD given, this is a main switch, and this is active neutral arc. So that you have to complete this circuit diagram. The whole wiring system, cable is widely used. How much are cable size? Non-domestic wiring system, how much cable size are utilized? So this is that you have to find out the exercise. And this is a two-way system, two-way switching circuit. You study the two-way switching circuit. and also the operation temperature limit. Upgrading operation temperature limit, you can review those things. Then we can talk about the sustainability of the ecosystem. The ability of the ecosystem to continuously support the life form within it. This means that we have to be aware of this renewable energy aspect. When in the air there are enormous dangerous gas, it can damage the environment. Therefore, we have to use appropriate emission control, appropriate rapid removal is also important aspect. This is related to the sustainability. So that in this case, sustainability is bottom up as well as a top down. Bottom up means that from the shop floor level, all the sustainable practices are reported to the supervisor and the factory manager and to the authority, regulator, and the government step. In the meantime, the top down means the government's organization produce the sustainability procedure and practice, and those rules and regulations are the environment rule and regulations given to the factories organization, and the every shop floor level worker must follow it. So this is a sustainability work practice, a two-way, bottom up as well as a top to down. So the OHS Act is related to the responsibility and legislation. So the sustainable and the action practice is that we have to reduce the physical and resources across to water and energy. And also we have to encourage recycling, we have to increase the use of the renewable energy sources, and we have to encourage and design a production process and products to eliminate the production of toxic materials. Those are the important aspects for the sustainability. And then we also have to protect and restore the nature habitats and the environment value for the biodiversity and the beauty. So in this case, sustainability practice is very related to the Kyoto Protocol. Kyoto Protocol is a reduction of the oxygen and greenhouse gases, carbon dioxide, methane, nitrous oxide, sulfur, hydrofluoride. Those are the greenhouse gases. Those greenhouse gases must be reduced. The economic benefit of a sustainable initiative is they are the challenge to the globalization and the demographic change. Because the greenhouse gas, some of the small island countries they will be damaging, so that the people will move to the other countries. So it can happen a demographic change. So this is the economic benefit is a sustainable initiative made. They are the challenge of the globalization and also demographic change. Economic benefit of the sustainable is also support the wider economic, social and environmental goals. In the meantime, it can develop the knowledge and the innovation. So they are very related to the sustainability. So consequence of the greenhouse gas is that they are major part in the shaping the Earth climate, also internal, external, to the climate system. Because of the climate change, it happens the Earth temperature is rising, and nature and human influence that force a change of the climate. So we have to observe the behavior of the climate. We have to do the scientific concern. We have to design the climate model, and we have to design the coordination action. We have to implement the coordination action and also the scientific assessment. They are all related to the sustainability practice. Sustainability practice means we have to monitor the change of the Earth temperature. We have to find out the nature, human influence that force the change of climate. We have to observe the behavior of the climate. We have to concern about the scientific concern and climate model. We have to coordinate the action and also scientific assessment. They are very related to the sustainability practice. So I do this thing this trade tools lesson, the higher trade lesson. What I give you today is that I explain you about the sustainable practice. In the meantime, I teach you about the wiring system. wiring system, lighting wiring system. I give you the look at the switch method, and also I give you the two-way switching method, and also I give you the fire safety, how to relating and clearance from the ceiling and from the other equipment. I also give you the configuration of the main supply system. Main supply system is the main switch, consumer, main RCD, and also the non-earthing link, neutral link, and the connection I give you. So this is for the higher stage of trade study. I give you this lesson. Then I will continue to do this workshop practice. Workshop practice 1. Okay, so firstly we're talking about the occupational health and safety for the electrical trades beginners students. So in this case, we have to be aware of the work environment. If you are working in the factory or if you are working at the work site, you have to be aware of the work environment. Place of the environment and the base of the operation and the location of the workers. They are the work site environment. Who can hold this WHS entry permit? This means that any you want to work in the industry, you cannot do the job. You have to have the OHS card, induction card. This is the white card. You have to get a complete training, and then you can go do this card. So this WHS entry permit is you have to appropriately train the people or the elected officer union or employer union, authorized person, including the workers. They must have a certificately completed prescribed training. So this is for the important aspect of OHS card. Free and proper person are the designation of the commission. They are, if the commissions are certified with, the holder can hold a permit, and then they can enter the workplace. So the negligibles are incident. Notice tables are incident mean when the incident happens, the death of the person or serious injuries or illness and dangerous incidents are arising, and also the outward period of buying the business or the workplace. This is the notifications are incident. Those notification incidents related to the employee, contractor, and a member of the public. So we have to control. So the way to stop what is causing the hazard, we have to use a lower hazard alternative, separate use from the rest of the workplace. So because of the hazard place must be separated from the other workplace, and then we have to utilize the appropriate installments equipment. Appropriate equipment need to be installed, and then we have to change the PPS on the working style, and also personal protective equipment (PPE) must be utilized. So this is where the appropriate workplace procedure. So when you are using as a hazard, so we have to work procedure. Firstly, what requiring a standard work procedure. So we have to focus on the standard work procedure, what to have to done. And then we have to break the task into the various steps. The whole work process need to be divided into the pieces, and then every piece you have to identify the hazard, and then we have to modify whether every step need to be modified for safer or not. It's safer, and then we have to follow the standard work procedure. You have to break the task and then identify hazard, and also the safer. If no, we have to change the work like this. So that in this case, so that in this case, that does need to be cannot be modified for the safer or easier. You have to develop the control measure and safety precaution, and you have to write down the standard procedure to control the measure, the safety and precaution, and then those procedures need to be audited regularly. So this is the important aspect of this occupational health safety. So this overview plans are shown that the how to produce occupational health safety are things. So that any workplace, there are the hazards. The hazards are the noise, all the equipment are running with a heavy noise, or radiation, light, vibration, temperature, humidity, ergonomics, moisture, dust, solvent, glue, flux. Also the virus, plus parasite, vermin, insect, slip, trip, and fall, two of the electrical equipment. Those are the hazards in the workplace. Those hazards need to be aware of. Okay, you are the electric apprentice, you need to connect the electrical motor to power supply. So you have to do that safely. Write down the procedure to connect the electric motor to power supply. So firstly, you have to check the motor rating voltage and the current by looking at the nameplate. Then you have to check the type of the motor. What is your type of the motor, whether AC or DC. You have to measure the supply voltage by the meter. You have to test the motor insulation resistance by the mega, and you have to check any damage on the body or not. You have to check the terminal plus supply cord, use the insulation, and then you have to handle the motor, you have to join the supply. You need to observe the name and vibration of the motor. If you are working in the petrol station, what safe method to be followed to avoid the risk of the explosion and gas? In this case, when you are working in the petrol station, there must be no bell connector, no battery charger, no discharge lamp. You have to follow the hazard principle of the year 3000. Now, those things are preventing the risks. And you have to remove all the ignition substance from the petrol station, and you have to remove all power point that can start the ignition. So this is the isolation rise. And then you have to allocate the appropriate carbon dioxide fire extinguisher to reduce the risk. So those things have to be done. So the biological hazard means the physical hazard are the straight fall, vibration, radiation, noise, unguarded machine, electrical shock. Ergonomic hazards are the type of the work, frequency, body position, poor lighting, improperly adjusted workstation. They can cause the stress on the body. Chemical hazard, they are the chemical produce solid, liquid, and cleaning agent, also the vapor, fuel, dangerous gas, they are chemical hazard. And biological hazards are animal, plant, bacteria, and insect. So any fire hazard is caused by the pure heat and oxygen. So the two causes of fire, pure is the main thing, and pure heat oxygen. If you let something, fire will not happen. Therefore, if you want to extinguish the fire, cooling means that by using the water, removing the heat, or they use the CO2 to prevent the water, air. So this is pure heat and oxygen. Three things are important for the fire. So if you want to extinguish a fire, you have to remove one thing. So they are the different type of the fire extinguisher. Flue type fire extinguishers are the contain the aqueous solution, fully form the concentrated and washer. They are extinguish liquid fire. Wet chemical fire extinguishers are aqueous solution to fire spray. They cool the surface to remove the heat element. Dry chemical fire extinguishers are they are spray oxygen element on the fire from the fuel. The powder also disrupt the chemical reaction. Water extinguisher are the to extinguish the solid fire. So this is the carbon dioxide fire extinguisher. They display the oxygen element of the fire. So this is for the kind of the fire extinguisher and the type of the fire you have to utilize. So this table means a class of the fire. If you fire is a solid wood paper, you can use a phone dye, wet chemical, dry dye, water, but you can use a carbon dioxide. Premier liquid, you can use a phone dye, but you can use a wet chemical, you can use a dry chemical, you cannot use a water, you can use a carbon dioxide. Flammable gas, you cannot use a phone dye, you cannot use a wet chemical, you can utilize a dry chemical, you cannot use a water, you cannot use a carbon dioxide. Electrical fire, you cannot use a phone dye, you cannot use a wet chemical, you can utilize a dry chemical, you cannot use a water, you can use a carbon dioxide. Cooking oil effect, you can use a phone dye fire extinguisher, wet chemical, you can use dry chemical, you can use, but you can't use a water and you can't use a carbon dioxide. This is for the how to use a appropriate use a kind of the fire extinguisher for the type of the fires. In the meantime, this is for the first part of the occupational health safety. Then we are talking about the drill and drilling. Drilling operation is used to mark the hole in the job when you like using the rotating cutting tool. This is called a drill. So this is the form of the drill. It means that here you got the thumb, this is a more stable, here is a helix, this angle, here is helix and here is flue. So this thing is a body clearance. So when you cut the drill, you can see the body clearance in this one. So this is the cut angle. Here is a diameter. And here you see from the back, the front, you can see like this. From the side, you can see the front, and this angle is a point angle. Cutting edge is a working part of the drill, must be the in contact with the jaw. So this is cutting edge. Chisel edge are located the drill and the form the pivot point. So this is for the drilling. The drill bit, view of the drill bit and their components. So flue is a helical group, shunt is a straight push point. So this is about we can do the flue, shunt. They are technical terms, and also the cutting clearance angle. Here this is the tip of the drill. This is the point angle. This is a half point angle. So this is a lip point, the clearance angle. So the length and the point angle and the lip clearance angles are main problem. If the length and the point angles are not proper, so that they cannot cut properly. So the correct location of the point is also important aspect. So sometimes you are using the overside or underside, so it can happen the overside underside drill. It can also affect your drilling. So then we are talking using about the drilling machine. So this is the picture of the drilling machine. Here is base, here is work table, here is vise. So on the vise you can hold your equipment, and here is drill bit. You have to attach a drill bit, and here you got the bell motor and handle lever. So when you drive the hand lever and you put down, and drill bit will penetrate your work equipment. So this is our work equipment. So in your practice, you can cut the tip metal pieces and you have to drill it. So in this case, you put the metal pieces here is jaw, here you can put the timber, and you can attach with a vise, and then you can drill it. So that your predicate, you cut the metal piece and you can drill. So here is a fastener. This is a bucket head fastener. They utilize for a light angle steel. Here is a dynamo. Dynamo is a dynamo, a two sleeve anchor and a masonry. Here with a here is a screw. So you got a flat blade, shank, push screw. Here heavy toggle. Here is spring toggle. So they are kind of the fitting equipment we have utilized in the workshop. Course we use for the heavy duty fishing timber. Braidboard is a drill using the tungsten tapered drill side. There are two kinds of the drill bit. You can use the drill bit utilized for the metal cutting cannot be used for the concrete. So you have to utilize the tungsten tapered drill bit. So this is braidboard. You can utilize tungsten tapered drill bit. So this is the drilling machine construction, and you have to use as drilling the wall pieces. Okay, so this aspect is for the trade one student. What I taught you is occupational health, safety, and work environment. And also, I explain you about the drilling. So I explain you about the drilling machine, use of the drilling, also the kind of the fitting materials. So those things I will utilize. Now that I continue to teach you the advanced diploma. Advanced diploma is electrical circuits. So the advanced diploma, we're talking about that. I will explain you about the DC circuit.
TCC circuit. So R1 and R2 are connected in series. In this case, total resistance R today is equal to R1 plus R2. When the current I is the same current flowing across the R1 and R2. So when the current I flowing across it, flowing through the R2, the voltage V1. Voltage V1 can be calculated. So V1 is going to get R1 multiplies I. Similarly, the currents are passing through the R2, voltage will be V2. V2 is equal to get I multiplies the R2. Therefore, the total voltage V can be calculated. V is equal to V1 plus V2. Okay. This is for the series circuit. R today is R1 plus R2. Voltage today is V1 plus V2. The total current can be calculated. Total voltage divided by total resistance. So total voltage V divided by total resistance R1 plus R2. So this is the DC series circuit formula. Okay, this solves the sixth problem. The four resistors 1 ohm, 2 ohm, 3 ohm, 4 ohm are connected in series to the 5 volt supply. Calculate the circuit current and the potential difference across each resistor. So the R1 1 ohm, R2 2 ohm, R3 3 ohm, R4 4 ohm, they are connected in series to the 5 volt. So the firstly we are calculating the total resistance. R today is R1 plus R2 plus R3 plus R4. So 1 plus 2 plus 3 plus 4, you call it 10 ohm. So the I today can be calculated. Voltage divided by R today. 5 by 10, so 0.5 ampere. So the current 0.5 ampere are passing through the 1 ohm resistor R1, so V1 is ID R1. 0.5 multiplied 1, so 0.5 ohm. V2 is ID R2, 0.5 multiplied 2, 1 ohm. 1 ohm. And the V3 is equal to ID R3, 0.5 multiplied 3, 1.5 ohm. V4 is the ID multiplied R4, 0.5 multiplied 4, that will equal to 2. So this is for the series circuit calculation. Another problem. A 2.2 kilo ohm resistor is connected in series with a resistor or unknown value across a 16 volt supply. If the circuit current is a 5 ampere, calculate the value of unknown resistor. So this is the 2.2 kilo ohm resistor and the resistor are connected in series. They connected to the 5 milliamp to a 16 volt supply. So the current is a 5 milliampere. So firstly we calculate the RD. 2.2 K plus R. R to the can be calculated, voltage divided by the current. V by I is the RT, so 16 by 5 into 10 power minus 3, so that was a 3 by 3 kilo ohm. So 3 by 2 is equal to 2 by 2 plus R, so the R is equal to 3 by 2 minus 2 by 2 equal to 1 kilo ohm. Another problem, two resistors are connected in series to a 150 volt supply. One is a node to have a resistance of 470 ohm. A voltmeter connected across it shows a reading of the 47 ohm. So the 470 ohm and another resistor are connected, and the voltmeter is connection here 47 volt. And so the total voltage is a 150 volt supply. Calculate the value of second resistor V, the circuit current. So the first is the total the current flow to the this resistor. So only 47, resistance 474. So 47 by 470 equal the current. I equal to V1 by R1. 47 by 470 equal to 0.1 ampere. So this is the 0.1 ampere current flow. And then some V1 plus V2, the resistor connected is series. V1 plus V2 is a total voltage 150. So the V1 47, total voltage 150, so V2 is 150 minus 47, so equal to 68. This is V2. So the same current flowing, so that you can calculate the R2. R2 is a V2 by I. So V2 is 68 volt. The current is 0.1 ampere, so you call it 680 ohm. So based on the DC circuits, series circuits, theory, you have to do electrical workshop, E003, topic 8, DC circuit, study the slide 1 to 9, do the exercises from question 67 to question 72.
Okay, this is for the DC circuits of CD circuit. Here is parallel circuit. For the electrical diploma DC calculation, I start with the DC circuit calculation.
Okay, this is the DC parallel circuit. R1, R2, R3 connected in parallel. So the current flow to the R1, I1, current flow to R2 is I2, current flow to R3 is I3. I1 is going to be by R1 because the parallel connection is same only. I2 is a B by R2, I3 is a B by R3. So the current I3 is equal to I1 plus I2 plus I3. And for the parallel connection, 1 by RD equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation for the parallel connection. Okay, we saw this problem. The resistor of 5 ohm, 10 ohm, and 30 ohm are connected in parallel with 12 ohm supply. Calculate the supply current. 5 ohm, 10 ohm, 30 ohm connected across the 12 ohm supply. I1 is going to be by R1, 12 by 5, 2 by 4 ampere. I2 is going to be by R2, 12 by 10, 1 by 2 ampere. I3 is B by R3, 12 by 30, 2 by 4 ampere. So the current is I1 plus I2 plus I3. So you add 2 by 4 plus 1 by 2 plus 2 by 4 equal to 4 ampere. So another problem. The resistor of the 33 kilo ohm and 68 kilo ohm are connected in parallel to a 50 ohm supply. Calculate K to the circuit resistance, C to the circuit current, and C the individual branch current. So the 33 kilo ohm and 68 kilo ohm connected parallel to the 50 ohm supply. So this is the resistor, two resistors connected in parallel. R to the can be calculated 1 by RD equal to 1 by R1 plus 1 by R2. So 1 by 33 plus 1 by 68. So by solving this one, R to the is 22 by 2. So the I to the can be calculated. 40 divided by R to the. So the 50 divided by R to the is 22 by 2. So 2 by 2 5 milliampere. And after that, I1 can also be calculated. So the 50 divided by 33 kilo ohm. So the 50 by 33 K. So 1 by 5 milliampere. I2 can calculate that. So the 50 by 68 kilo ohm. 50 by 68 K. So 0.79 milliampere. So this is for the parallel circuit equation. So another problem. The resistors of the value 12 ohm and 8 ohm are connected in the parallel with a resistor R3 or unknown value across 6 volt supply. So the 12 ohm, 8 ohm connected parallel and R3 connected to the 6 volt supply. When the current from the supply is found to be 2 by 2 by ampere, so the current flow is 2 by 2 by ampere. Calculate the value of the R3, the current flow into the R3. So first reason to the current 2 by 2 5. So if you need to find the I1 current, I2 current, so started from the 2 by 2 5, you got this I3. And then the body divided by I3, you will got this R3. This is the way we will solve the problem. So first we calculate R1. B by R1. So the body is 6 volt, R1 12, so 0.5 ampere. I2, so body is 6 volt divided by 8 ohm, so 0.75. So I1 plus I2 plus I3 is the I total. So the I1 0.5, I2 0.75 plus I3 is equal to I total 2 by 2 5. From here I3 you can calculate 1 ampere. So the I3 is 1 ampere. So the body is simple across the R3. So the R3 can be calculated B by I3. So 6 by 1 equal to 6 ohm. So R3 will be 6 ohm. So based on the low example and theory, just to do balance electrical workshop E003 slide 10 to 17. Do the exercises from question 73 to question 77.
And now we're talking about the series parallel circuit.
This is the DC series and the parallel circuit. So total are voltage. The total resistance R1, resistance R1, R2, R3 are connected like this. So R2 and R3 connected in parallel, and the whole combination connected in series with R1. So the current ID, the voltage across the R2, R3 is the common voltage V2, current flow into R2 is I2, and current flow into R3 is I3. So R2 that can be calculated R1 plus R2, R3 divided by R3 plus R3. I2 there is a V by R3. So the voltage V1 can be calculated ID multiplied R1. So V1 plus V2 3 is a total voltage V. So the V2 3 is going to be V minus V1. I2 can be calculated V2 3 by R2. I3 can be calculated, so V2 3 by R3. This is the way how we calculate the series and parallel circuit. Okay, this problem. One of the resistors is connected in series with the parallel combination of a 6 ohm and a 3 ohm resistor to a 6 volt supply. Calculate the effective over all the system of the circuit, be the current in each of the 3 resistors. So this is for the 6 ohm and 3 ohm connected in parallel. The whole combination is series resistor. The 1 ohm. So the voltage with the 6 ohm. R2 can be calculated. The formula is R2 and R3 parallel. R1 plus R2, R3 divided by R2 plus R3. So 1 plus 6, 3 divided by 6 plus 3. So to the resistance will be 5. So I2 there is equal to 3 by R2. So to the voltage is 6 volt. R2 there 3, so that you call it 3 ampere. So this 2 ampere flowing together R1. R1 1 ohm. So the V1 can be calculated ID multiplied R1. 2 ampere multiplied 1 ohm, so V2 3. V2 3, so the total voltage are V minus V1, you call it V2 3. So V2 3 is a V minus V1. This is minus 2, 4 volt. So the V2 3 4 volt. V2 3 4 volt divided in R2 6 3, 6 ohm, you call it I2 is 0.6 ampere. V2 3 4 volt divided by R3 3 ohm, you call it 1 by 3 ampere. So this is for the series parallel combination. We can calculate it. Another problem. The resistor of the 2 by 2 kilo ohm and 7 by 8 kilo ohm are connected in series and in parallel across the seconds are series group of 3 by 3 kilo ohm and 2 by 7 kilo ohm. So 2 by 2 and the 7 by 8 connected series. Another group is 3 by 3 and 2 by 7 kilo ohm connected in series. Those series combination groups are connected in parallel. So they are connected to a 9 volt supply. The whole supply is a 9 volt. So we have to calculate total resistance or the circuit, either the current from the supply and in each resistor. So firstly, we calculate R12. So this is combination. You add R12 is equal to 2 by 2 plus 7 by 8, so 10 kilo ohm. R34, so R3 plus R4. 3 by 3 plus 2 by 7, you call it 6 kilo ohm. So 10 kilo ohm and 6 kilo ohm are connected in parallel. So the R2 that can be calculated. The formula is R12 multiplied by R34 divided by R12 plus R34. So 10 multiplied by 6 divided by 10 plus 6, so 3.75 kilo ohm. So I2 that can be calculated. V by R2 there. So voltage 9 volt, R2 there 3.75 kilo ohm, so 2.4. And similarly, I12 is voltage by R12. V by R12, so 9 volt by 10 kilo ohm, so 0.9 ampere. I34, V by R34. V by R34. So the V by 9 volt divided by 6 kilo, so 1.5 ampere. So this is the way we can calculate this voltage current in the series parallel combination.
My job is to make college easier because students have a lot on their plates. Like Harper, an econ major who piles on the pressure. Grammarly can help her stress less.
This term paper's gotta be great. It's a third of my grade.
Your ideas are on the money. Let's make sure they come across clearly with Grammarly. Watch it work. Watch it work.
Wow, that is stronger.
And Avery, an engineering major who runs on ambition and coffee. Grammarly can get her dream job.
My application needs to stand out. They only meet with the top candidates.
If you want to make a good impression and nail your delivery, use Grammarly. You don't want to pull another all-nighter, do you? Now that's taking it to the end zone. Yeah. Oh, touchdown with Grammarly. And Blake, an education major who knows what he wants. So you're going to be a school teacher.
Yeah, but first I need to get my senior thesis over the finish line. I keep repeating the same words.
Let Grammarly help you find the right words faster. Grammarly, do your magic. And you did it in one place. Grammarly means better results. That's why it's the writing tool selected by 3,000 schools and universities. Try Grammarly for free by clicking the blue button. Class dismissed.
Okay, now we are talking about the series per circuit 2.
Five resistors are connected in series by the grouping resistance supply as shown in figure. So these reports are R1 2 ohm, R2 8 ohm, R3 3 ohm, R4 6 ohm connected parallel. So this parallel combination connected in series. So the current flow to R1 is I1, current flow to R2 is I2, flow into R3, I3, flow into the R4 is I4. Then the combination connected across is another R5 is 7 by 2 so the current flow to the R5 is 5, I5. So total voltage is a 6 volt. So we have to calculate total resistance on the circuit. So the R1 and R2 connected in parallel. So R12 is equal to R1 R2 divided by R1 plus R3. So the 2 multiplied 8 divided by 2 plus 8, so 1 by 6 volt. R3 4 connected parallel. R3 R4 divided by R3 plus R4. 3 multiplied 6 divided by 3 plus 6, so 2 ohm. So the R12 is 1 by 6 ohm, R34 is 2 ohm. The combination is the R5 7 by 2 ohm. So then we can add R12 3 4. R12 plus R3 4. So this is a 1 by 6 plus 2, so 3 by 6 ohm. R5 7 by 2 ohm. Okay? So we have to find the total resistance of the circuit. Now we have to find the current provided by the supply. See the current flow into the 2 ohm resistor. So the R2 that can be calculated. R12 is a 3 by 6, R5 is 7 by 5. 7 by 2. So this two are parallel. R2 then is equal to R1 2 3 4 multiplied R5 divided by R1 2 3 4 plus R5. 3 by 6 multiplied 7 by 2 divided by 3 by 6 plus 7 by 2. So 2 by 4. And then you can also calculate I total. The voltage is 6 volt, R total 2 by 4. So 3 by R total. 6 by 2 by 4, 2 by 5. And after this, I1 2 3 4. Voltage 6 volt, R1 2 3 4. So 6 volt voltage divided by R1 2 3 4. You can find the I1 2 3 4. I1 2 3 4 equal to P by R1 2 3 4. 6 volt divided by 3 by 6, so 1 by 6 7 ampere. So this 1 by 6 ampere also flow to the R12, also flow to R32. So therefore the V12 is a I1 2 3 4 multiplied R12. So 1 by 6 7 multiplied 1 by 6 2 by 6 7 4. This 2 by 6 7 4 is also across the R1 and R2. So then we want to find a 2 ohm resistance. So we have to find I1. So IR1 is a I2 ohm. So V1 by R1. So 2 by 6 7 divided by 2. 1 by 3 is the ampere. This is the series current combination. We can calculate the current in the required branch. And the power is going to voltage multiplying current. So V multiplying I. This is what is power. Or the voltage squared by resistance. V squared by R. Or the current squared multiplying resistance. I squared by R. I squared multiplying R. So it's a total power PT is equal to V1 plus V2. So the two resistors are connected in parallel. The total power can be calculated. Power in resistor 1 plus power in resistor 2. So in this problem, a circuit consists of 1 by 8 kilo ohm and 1 by 2 kilo ohm in series to a 12 volt supply. We have to calculate the power dissipated in each resistor and in the circuit power. So the R1 is a 1 by 8 kilo ohm, R2 is a 1 by 2 kilo ohm. Connected the city, they connected across a 12 volt supply. So then we have to find the resistance power and do the power. So first we have to find the resistance. So the resistance RD is equal to R1 plus R2. So 1 by 8 kilo ohm plus 1 by 2, so 3 kilo ohm. Then to the body 12 volt, to the resistance. So body divided to the resistance, you can find the current. I today is a P by RT. So 12 divided by 3 kilo, so you got a 4 milliampere. So the 4 milliampere passing through the R1. I square R1, so you got the P1. P1 is square to the IT square R1, so 4 into 10 power minus square, multiplying 1 by 8, so this is about 0.0388 watt. P2, IT square R2. So 4 into 10 power minus d square, multiply 1 by 2 into 10 power 3, 0.043. So this is P1, P2 you got. So P2 there is equal to P1 plus P2. So by adding P1, P2, you got the P2 there, 0.0481. Similarly, we also calculate another formula. Power today is body multiplied current today. So body is 12 volt, current today is 4 milliampere, 4 into 10 power minus 3. Then also we calculated 0.0481.
And then we're talking about the land resistor circuit.
Today topic is the lens and the resistor circuit. The three filament lens indicators are each one at the 12 ohm and 0.36 watt. If they are connected in series, what supply voltage should be used, what circuit current will flow, and what power will the circuit dissipate. So these are three lens. So all identical, 12 ohm 0.36 watt. The supply voltage VD. So the supply voltage can be calculated all the voltage of the all lengths. 12 plus 12 plus 12 equals the circuit voltage. Each length current. So in this case, this is the power, this is voltage, power divided by voltage. P by V, you got the current of 0.3 ampere. This 0.3 ampere flows the all length. So the power today is going to VD multiplied ID. So the voltage is a 36 volt. So the current is a 0.03, so you got a 1 by 0.038 watt. So this is the way you can calculate the total power. Similarly, you can also add the total power. So the power is going to additional all power. So total power PD equal to P1 plus P2 plus P3. So 0.36 plus 0.36 plus 0.36, you got a 1 by 0.81. So this is the way we can calculate the total power in the current. In the meantime, our two lengths are now connected to the parallel. The same threes are 12 volt 0.361 lengths are connected to the parallel. Find the supply voltage, circuit current, and to the power dissipated. So this is 12 volt 0.361, 12 volt 0.361, 12 volt 0.361. Those threes are connected to parallel. So I1 can be calculated D by V, 0.36 by 12, 0.03 ampere. I2 is a P by V, so the 0.36 by 12, so 0.03 ampere. I3 is a P by V, 0.36 by 12, so 0.03 ampere. I2 there is equal to I1 plus I2 plus I3. So the 0.03 plus 0.03 plus 0.03, so the 0.09 ampere. Power total can be calculated VT multiplied by IT. So total voltage is 12 volt, total current is 0.08. 0.09 today. 12 multiplied by 0.09, 1 by 0.81. So this is the way that we can calculate the CV and parameter combination of the length. Now we see there's a potential divider. So to the body here, resistor R1, R2 CD. So V1 across the R1, V2 across the R2. So V1 can be calculated VD multiplied R1 by R1 plus R2. V2 can be calculated VD multiplied R2 by R1 plus R2. So this is the way that we calculate the V1 and V1. Okay, this problem. A circuit is a fair width is a 9 volts supply, but the 4 volt voltage share to ground is required. So this is for the supply in 9 volt. So this is a transistor. You only need a 4 volt to supply the transistor. So therefore the way we use the potential divider R1 and R2 CD. So the 4 volt potential to the ground is required at the base of the battery. Calculate the value of the second resistance. This is the R1 value we calculate and forming the necessary potential divider. So in this case, the total supply voltage is 9 volt. So this is this transistor, the base voltage is only the 4 volt. So 9 out of the 4 out of the 9 volt is supplied to the base. So this is for the BR2. BR2 can be calculated V2 there, multiply with R2 divided by R1 plus R2. BR2 equal to VT multiply R2 by R1 plus R2. So the BR2 is 4 volts, V2 is 9. R2 is 12, R1 unknown, R2 is a 12. So by this way, we change the position. R1 plus 12 is equal to the 9 plus multiply 12 divided by 4, so 27. R1 plus 12 is 27, so R1 is equal to the 27 minus 12, so that's 28 kilovolts.
Okay, the last problem, we are talking about the Wheatstone bridge.
So this is the Wheatstone bridge. We connect the current circuit this way. So when the bridge is balanced, I1 current flow here, the same current flow to the R3. I2 current flow here, the same current flow to the R4. So normally I1 R1, I2 I3 R3, I2 R2, and I4 R4 flowing. Bridge balance condition, I1 into R1 equal to I2 into R2. And similarly, the I3 into R3 equal to the I4 into R4. So we divide equation 1 by 2. So I1 R1 divided by I3 R3 equal to I2 R2 divided by I4 R4. But the balance conditions are I1 equal to the I3, I2 equal to I4. So therefore, we can say I1 I3 can say I2 I4 can say R1 by R3 equal to R2 by R4. So this is the bridge balance that we can write in this equation. Okay, we see this problem. The bridge circuit in the figure has a following value at the balance. R1 is 1000 ohm, R2 1000 ohm, R3 27150 ohm. Calculate the value of the unknown resistor R8. This circuit we can write out IA into R1 is equal to the IB into R2. So equation 1, IA into R8 is equal to IB into R3. So 1 divided by 2, IA R1 by IA R8 is equal to IB R2 by IB R3. So IA cancel, R1 by IA is R2 by R3. So you substitute. R1 is 1000, R2 is 1000, R3 2715. Then you can calculate R8 as 2715. Now this is for the battery calculation. So all the battery got the inner resistance R, electromotive voltage is the E, terminal voltage is B. So V is equal to E multiply I. In the meantime, you can also calculate to the current I. To the current I of the battery can be calculated E by internal resistance plus external resistance. This is for the E divided by the R, capital R plus small r. Therefore, you can also calculate the battery current. So battery equation is that when you connect the battery in series, you have to add the other electromotive force and also the internal resistance. Okay, this is problem. It has an E and F on the 1.5 volt and the internal resistance of 0.5 ohm. Calculate the terminal voltage on no load. These are when providing a current 200 milliampere. When connected to a load or the resistance 8 ohm. Firstly, we write down the equation for the electromotive force. E is equal to B plus IR. So terminal voltage is electromotive for 1.5 volt. We don't know the terminal voltage. The current is 0 because the no load is the I0. So small R.5. So therefore the use of the terminal voltage also the 1.5 V. V, when the providing current of 200 milliampere. Right now the equation E equal to V plus IR. So V is 1.5, E is a 1.5 V unknown, I is a 200 milliampere, 200 is a 103, I is a 0.5. By solving this one of V equal to 1.4. So the another thing is that we connected to the load resistance AO. When you connect the load resistance AO, we first have to calculate the current. So the current is going to E divided by small r plus capital R. So the 1.5 divided by E plus 0.5, and the 0.176 ampere. So we substitute this equation, E equal to V plus IR. So 1.5 equal to V plus 0.176.5. So from here you got the V is the 1.41. Another problem, the battery is made by the connected in the A cell in series. Each cell has an EMF of 1.5 volt, internal resistance 0.35 volt. You can calculate the total electromotive force, ET, total internal resistance RT. D, terminal voltage at the 300 milliampere. So the ET is when each cell got the 1.5 volt, so let's say 8. 1.5 multiplied is a 12. Each cell gets the internal resistance 0.85, so let's say 8. So the RT equal to 0.35 multiplied 8, so it's 2.8. So we write down the equation, ED is equal to VD plus I into RT. So ED is a 12, VD unknown, so the current is here given as 300 milliampere, 300 is 1 minus 3, RT 2.8. By solving this one, V today is terminal voltage at 10.11.
Okay, so today's lesson, I summarize all lesson what I give you. Firstly, I talking about the Bachelor of Applied Engineering. So degree level course, I talk about the reassessment and occupational standard, and also the professional ethics of the engineer. And I also talk about the overview design of the electrical supply system. In this case, how to select the cable side and switch gear, and also the cable selection, basic overview of the cable selection, configuration of the production system. And regarding the electrical trade, trades are higher trade level. I talk about the building wiring circuit, so light connection of the lighting circuit. And also I talk about the sustainability. And lower level of trade, I talk about the occupational health, safety, work environment. And I talk about the cutting and drilling. And regarding the advanced diploma, I talk about the DC circuit product. So this is all for the today's my lesson. So I will also make the video and I will post to the YouTube, as well as I will share into the my website. The website is this one. You go to the www.iqitechnicalcollege.com. This is a main website. On the main website, weekly lessons I will be post YouTube like this. So they go to here, weekly lesson.htm. To the weekly lesson.htm. So that I already posted 6 February 2022 last week. This overview of the program. So today's 13 February I will post, so that you can click the YouTube video link and you can get this learners video by online from the our weekly lesson link. And also the Google meeting link, click the Google meeting link. So the link one is every Sundays at 10 a.m. The live lesson I deliver at the link one. So by clicking the this link one, you can access the lesson. So this is a live lesson. So all the live lesson will also be posted to my website. So go to the www.iqitechnicalcollege.com and then going down, then you can see the Google weekly lesson on HTM. By clicking the weekly lesson on HTM, you can see the Bachelor of Applied Engineering, Electrical Electronics video. So 6 February, I already finished. And now it's 13 February. 13 February, those lessons are include the degree level Bachelor of Applied Engineering, also the electrical trade, so lower level trade and higher level trade, as well as the advanced diploma. So those video and the lesson I will be delivered. So I will put to the upload to the YouTube and also I can upload. In the meantime, I will also share into my guideline on the Facebook as well as into the electrician group that I am member. Thank you very much for today.